So this talk is JSON API and GraphQL, fast friends. I am Ryan Tablata. This is a lightning talk, so if you saw me at NashAPI, I gave kind of a broader talk on this. This is a little bit more in-depth, or a little bit less in-depth in like implementation-y and kind of broader view and how they relate to each other. I work at a company called Prototypal. We do product development, consulting, training, staff augmentation, all sorts of stuff. And we also have a product that we have called EmberCast, which is Ember and JavaScript training. But specifically, since I'm going to be talking about JSON API, it applies because we have full stack courses in Node, Rails, Phoenix, and quote unquote launching in early access later this week, as in tomorrow when I put it in the database, a C#.NET course where you build a JSON API and the Ember front end and talk back and forth and see how these pieces of data interact with each other. So, APIs. REST is dead if you follow Twitter or Y Combinator or know that I just like to stir up a pot of drama. Well, I'm going to argue that no, not really, especially because this is a talk about REST, and it's more actually talk, especially since I've kind of rebuilt it to talk about more GraphQL than the regular talk and took out other things. It's about data design, how we build our data already, and it's more about how we think about it and how we access it. How can we, from a front-end application or an iOS application or a public API, access data that we have in databases or S3 files or whatever? And it's changing the way that we think about data using kind of these two paradigms of JSON API and GraphQL. This is usually where I would say, let's look at traditional REST, and the examples I'm going to be using are the Star Wars APIs. So later, not during the other talk, of course, but later go to swappy.co/API and just try to find data without reading any of their documentations. Good luck. So data in our database or in Mongo or whatever looks kind of like this. And this is the mental model that we often have as developers about our database structure. So this is actually from the Star Wars API database. There's rows of data in tables, right? We think of these different rows and pieces. If you're in Mongo, maybe it's objects in a collection, or keys and values in Redis or whatever, and they just kind of stand alone. But that's really boring. If all I have is a planet, or all I have is a film or a character, that doesn't make much sense, right? If you think of Twitter or Facebook, if a post, all it had was the text of that post or the image, it wouldn't have much value. What actually makes value is when you start adding relational data. When a post has who created it, who liked it. And in this data set, there's things like a species has a home world, and of course, for some reason, my slide presentation doesn't feel like getting the HD version of this image, but that says home world ID. So each species, it kind of has this pointer, this big like arm and finger saying, if you want more data that's kind of around my universe, go look over there. In fact, in databases, we often have things called join tables, or this idea of join tables, where there's not really any data except for two ends of kind of this string. And we're traditionally thinking of collections in like a NoSQL database or in a relational database, and we're just thinking of rows and tables and like CSVs, basically. But what we're actually creating is a graph of data. We're actually kind of creating the like detective wall with pins and points and string going between everything, pointing to everything. And in fact, I've got a live demo using a software called Neo4j, which is a database. So it's, instead of SQL, you use Neo4j. Really, I'm doing this just for the visualization. Almost all my applications actually use SQL or something else as its data store. But I like Neo4j because I can ask for data and it shows me kind of that like board of pictures and dots and strings. So there's planets in pink and vehicles in red and starships in yellow and all sorts of data, and you can see how they tie to each other and how you can go along things. And it's kind of hard to see right here, but let's kind of drill in and see something a little bit deeper. So I've got a query that is saying, go look for Luke Skywalker, and then kind of go along one path, and then find another path and go down that till you find another person. So if I run this, here's the result that I get. So somewhere on here is Luke. Usually I would find it. He's in there. But the blue are all the films that Luke Skywalker was in. And then I can find all of the other characters that are in that. So if you're thinking like in a UI on an application, you might have like the character screen with their profile picture and a little bit of data just about that one character. But then there's like a list of cards that are all the films that character was in. And then you can kind of click on one of those and get a quick preview of other characters that might be in there. And this is the data you would need for all of that UI. So we've got a graph of data. How do we access it? Well, obviously, we have a graph, so it's going to be GraphQL, Graph Query Language. So here's a live demo where we're going to actually go to, this is public, there's a GraphQL for the Star Wars API, and I've pre-typed this in because I always screw up this query. So what I've looked up was Luke Skywalker. This is the ID apparently assigned to him. And with GraphQL, you can kind of go into that circle that represents Luke Skywalker, and you say what the fields are you want. Who's seen a demo of like this for GraphQL? Yes? Some? Oh. Okay. But also I can get relationship information. I can go down those paths. I can look for information that I want related to it, or I can, which is what this home world is. So home world, I can actually go and find the planet that is attached to Luke Skywalker. And I can even go into the home world and ask for the name of that home world. And I can ask for the residents, all of the characters and people that are on that planet, which is really cool. But this does have a few different downsides and challenges. It's a new syntax. So if you're used to HTTP and just running up a curl request to like localhost 3000/planets, that's not there. You have to learn extra information. You have to learn this new syntax of how to send things and actually like what the response should be and how to pull that out. There's no like default of like give me all the people and you tell me what the format should be. You have to specify and know about that resource. Usually this is okay because it's your internal API and you've got the type definitions somewhere in an private NPM package that you pull in or whatever. But if you don't, then you're running to the docs. And you're saying, well, I asked for person, but you didn't give me anything. You didn't give me anything. How am I supposed to know that there's a name? Maybe they have that API Explorer turned off. How do you figure out what the API is like? The other thing is you need to know the context of the query. For the right-hand side to make sense, I have to know the left-hand side that was sent, or else it's just kind of regular data. I don't know what to do with Luke Skywalker unless I know that I sent this left-hand side. How do I cache it? How do I keep it around? What can I do with it from now on? And then if I was lazy loading data, like let's say you start scrolling and you need to know, oh, now what are the vehicles that Luke was in? What were the other things? I'm trying to think, the species and all that kind of stuff. How do you go and get that data? Again, you have to know intimate data. You have to know intimate information of how the API is organized. So this is where I'm going to point to JSON API. So at its core, JSON API and GraphQL have similar ideas. These dots, or these entry points into your graph of data that you're querying into or mutating, and then you can ask for data along the way. So I have a running version. I haven't made it public yet. I need to. I have a running version of the same data set using JSONAPI. And let me go ahead and pull this up. So if I go to localhost/people, this looks a little bit, if you're used to kind of a traditional HTTP resource, this looks very familiar. I just made a curl request or a fetch request. I didn't have to know anything about a syntax. I just sent a URL and I get some data back. Sweet. It may not be the exact format I want. We'll talk about that in a second. But I have data that I can work with. If I go inside of the data array, there's also something interesting in this information. So this is all formatted based on the JSON API specification. But if I go in this data array, each one of these objects is what I would call standalone. It tells me everything I need to know about it without knowing kind of that left-hand side of GraphQL. If I just got an object with type people ID 8, I might not know, did that come from an update request? Did that come from a patch? Did that come from a GET request? Did that come over a WebSocket of just streaming information to me? But I now have a way to cache this. I have a way to look it up. And if I have just a local dictionary, think of an object with people, and then you have a key for each item based on its ID, I could go to data.people number 8. Cool, and I've got that locally cached, and it's really easy for me to find. The other thing is attributes are kind of set aside and special. So if you think of that dot, everything that is on the object that only exists for that object is in attributes. So one of the things that's not specifically mentioned about JSON API, but is really cool when teaching it and thinking about it, is that nothing in attributes should have a side effect to another resource. If I change the name for person number 8 or people number 8, that only exists for that person. Those attributes are for that one person. And the reason that we don't need to put things like their home world and their species in attributes is because we have a dedicated relationships specification for how to get to other related resources that might either be shared or might be lazy loaded or whatever. So what if I wanted just the name for this person? Well, there's a specification. As part of the specification, kind of similar to the way that you can format your query in GraphQL, in JSON API, you can say, only give me the fields for the type person, and only give me name and height. And hopefully I spelled this right. Oh, no, this shouldn't be person, this should be people. So now it's only giving me the data I need back. So if I want to save network information, or maybe I only need to reload those resources because I was pretty sure that I had the other attributes locked down, then I can just request the data I need. Well, what about these relationships? Let's look at those. So each relationship has a link. So just using kind of what you're used to with HTTP in a browser, I can visit these links, I can follow the links, and I need to remember this is the actual relationship object, so that would be like that object right there. Related is what I want, which loads the data from it. And now, so if I scroll down the page and I'm like, oh, the user's about to need the planet information, I can follow that link and get that planet information without having to do a ton of work up front. So if I had a list and then popped open one of those people, I can kind of have like their quick profile, background load some information by following some of these relationship links, and populate what I need later. But also, the cool thing with GraphQL is people are like, oh, well, I have a person, but now I have to make another request to get the planets, which maybe you want to get all that information all at once. Here's include. So with include, I can say, give me the home world. And it doesn't look too much different at first. Oh, let me go to people/1 so that this is easier to find. It doesn't look too much different at first. I still see Luke Skywalker and the height, But if I start scrolling down, and there's something wrong with this implementation, I have to say also include the home world as the field. So I get the home world ID here, and notice I've got type and planets. So if I have that loaded locally, I can just say, hey, go to my local data store in iOS or in the browser or whatever and say, do I know about planet number 1? If not, I can load it by myself, or since I said include, if I scroll down, here's all my side-loaded data. So I can put this into my data object and look up planet number 1 now, and I've now got the planet for Luke. And anyone else who references planet number 1. Now this is the part where I would love to also do fields for planet, but for some reason this server is not responding to fields for planet. But by specification, I could also specify what are called sparse field sets for any type. So I could say fields planets equals name, and it would only return the name for the planets type. So the last thing I want to do is talk about the future of JSONAPI. One of the cool things with GraphQL is that it works pretty much over anything, because you're just sending a JSON object out, or you're sending a string query out, and you're getting back a JSON payload or a string payload back. So it works over WebSockets, it works over HTTP. But if you notice with JSONAPI, a lot of this stuff is like typing in a URL, typing in links and following those. So there's part of the JSON API specification called operations. So what we were doing before is we were making like a GET request to people/1 with fields for people equals name, comma, height, include is home world, fields, planets equals name. With operations, you can now do batches. So if I needed to get a bunch of resources all at once, I won't have to make 20 different API requests, although HTTP2 is cool, so But let's say I needed to get this information and then patch and then post and then delete, and if any of these things fail, undo everything. So this is where operations come into play, and that same URL can be represented as a JSON object where my operation is get, and then I have information like the type I'm trying to get, the ID I'm trying to get, what I want to include, what fields or sparse fields should be included. And you can actually run multiple operations at a time, kind of similar to what you can do with GraphQL. And then your operations, you get an array of results back. So I just kind of wanted to start making you think. So GraphQL has us starting to think in this idea of dots and branches, but maybe there's other ways we can access this data. Maybe there's other ways that we can describe it and explain it, visit it. We don't need, per se, Neo4j or a graph database with GraphQL and all the latest things. Maybe the change needs to be here instead of just in the code that we're writing. If you have any questions, I'll be hanging around, but I think that's it.